So today we have gathered here to build a HPC cluster with Raspberry Pi. So HPC means high performance computing, and there are several ways to build this kind of cluster. But why we are using Raspberry Pi? Because it's affordable and accessible. And the process that we are going to show here is very simple, and we made it in a way so that everyone can follow and everyone can make their own cluster using this particular steps. So first, of course, we need the hardware. So we need a couple of hardwares here. We have listed the things that we need here. So first of all, we need three Raspberry Pi, full Raspberry Pi 4B model, two for compute nodes, and one is of course for master node. So there is a preference. So if you feel that you have a bigger budget, you can always go for more number of compute nodes, and you can also opt for a master node with higher memory. Because if you go to this particular website, which is called Raspberry Pi org, which is the official website of Raspberry Pi org, you can find there are three different models: one with 8 GB memory, one with 4 GB memory, and one with 2 GB memory. And of course, based on the memory preference, you will have to pay more price. Then you need three MicroSD cards for three individual Raspberry Pis, because the MicroSD cards are basically the important part of the Raspberry Pi, because we will install the operating system there on these MicroSD cards. So there is no particular preference. You can always go for a minimum memory, but we will prefer 16 GB or higher, because we are planning it to use as a cluster. So you will have a lot more files for computation, and maybe you will produce more data. So it is advisable to get more memory. Then we have these three USB-C power cables. These USB-C power cables are pretty much common. You can shop those at Amazon. So one thing you can notice, there are links for every items, and these are not our suggestion. We are not promoting the website. These are just for just to have some ideas of what you are searching for and what kind of price you have to pay. Now we
You
have
can compare these prices with
yeah,
other.
yeah, of course. You can go for others if you feel that those are better, and if you have more budget, you can go for higher prices. So it's up to you. But this is the basic model. We have tried to find these items based on their lowest prices, and it should be still usable. It's not like it's a not cheap knockoff. It's original authenticate models, but it's the cheapest version that was available on Amazon.
Right. All
Uh,
total, I guess the amount of budget we spent is around $200 to $250 to make this whole Raspberry Pi stuff.
yeah. So yeah, it's a one-time investment, I suppose, and you can do a lot of different things with using this cluster. So we will explain those things later on one by one. But so let's move on to the next item, which is a Cat6 or Cat5 or Cat6 Ethernet cable. So you need the number that you can see here. It depends on the number of Raspberry Pi that you are using. So we are using three Raspberry Pi model, Raspberry Pi units. So we need three MicroSD cards. We need three USB-C power cables. We need three Ethernet cables for, just to connect the Raspberry Pis parallelly with this wireless router. And we also you can also use a network switch if you want, but in this description or in this approach that we are explaining here, we haven't used any network switch, just for the simplicity, but you can always use. And it's preferred when you use lots of different nodes. Now we have also used a 6-port USB power supply, but it's not mandatory. You can always connect those Raspberry Pi from your normal power outlet using a normal phone charger. But if it is there with you, then it should come in handy, and it is very useful in some way. And then we have this external storage device. So it might be an SSD hard or external hard drive or flash drive, or you also call it pen drive. So this can be up any memory, but we'll prefer it should be 16 GB or higher. So based on your budget, you can decide on that. And we also used a Raspberry Pi for cluster case, but it's not optional. But if you make it as a cluster, so it makes sense. Then if you stack it one by one, then it looks like cluster, and you can get efficient cooling in a different way. So I will explain the cooling part at some point of this procedure. So the first part will be to
Maybe
prepare.
maybe I can show the components in the
Yeah,
camera.
so yeah, that would be great. So I will stop sharing my screen, and
Right.
I think
So the first thing that we were talking about was the Raspberry Pi. So here you can see the Raspberry Pi.
this is the Raspberry Pi board, and
Right.
if you see carefully, the biggest chip that you can see in the middle is the Raspberry Pi processor, and on the left of that processor is the RAM or the memory.
Yeah.
And there are different outlets for this Raspberry Pi board. In the bottom side, you can see the Type C power inlet. So you can just the Type's USB power cables that we were talking about. We will connect it to these ports,
Right.
and
These are the
then
cables that we were talking about.
yeah,
Simple.
then we have true micro HDMI ports. Using these ports, you can connect external display or the monitor if you want. But in this particular procedure, we will not connect any kind of monitor. We will use this Raspberry Pi as a headless unit, so there will be no display or graphics. And then next to those micro HDMI inlet, we have this 3.5 audio jack. So of course, the Raspberry Pi is not only built for computation; it's also built for personal computers. So you might be interested in playing movies or doing some stuff where you need some microphone inlet or inlet. Okay, so we have this different. So one of the port on the extreme right is the network port, called Ethernet port. It's a 1 Gbps Ethernet port, so you can connect Ethernet cable to this unit, and you
For
can connect it.
example, these
And
cables that we were
yeah,
talking
yeah, and the other part of the cable will be connected to the router. Now we have four different USB ports. Two of them are 3.0 and two of them are 2.0. So yeah, so the 3.0 is of course the faster one. So we'll connect our pen drive to one of these units, and we'll explain it later. So when to connect it and when to power it up. But it is preferred that you will connect the pen drive or flash drive or external storage to one of these 3.0 port, the blue
Right.
ones.
We'll use it as scratch.
Yeah, we will use it as a scratch or shared storage, you can say.
Yes, correct. And in our script, we will be calling this space as shared directories or
Yeah.
shared card.
So this storage will be shared among all the other compute nodes, and we will use it as a common storage, and we will execute different tasks from there.
Well,
So we also we were also talking about the memory card that we're going to use. So this is one of the memory cards. This is a 32 GB PNY memory card, micro SD memory card. So we will insert it to the adapter that it has here on the left. It's a small. There is a small port there. You can just insert the memory card, and then you are good to go.
that's all.
Okay.
So I have
Okay.
two more such Raspberry Pis,
Yeah.
and stack it
Yeah.
like this.
So yeah, we are just stacking all the Raspberry Pis together. So the topmost Raspberry Pi will be called as master, and the bottom two will be called as worker nodes. So
Right. This is
this
just a choice. We are choosing this
the,
first one as master, and these two
yeah.
as worker
So
node.
this is just our convention. It's not be like that, but it is preferred that you put master on the extreme top, and you can just count from there on.
Sometimes,
So
sometimes it helps
it's
to
yeah,
it.
Yeah, it basically helps you to remember things in a way.
And cooling.
Yeah, and that is another part. Of course, the top node will be exposed to the air in a very efficient way, and your master will work harder, or will work harder compared to the worker node. So so you need more efficient cooling in the master node. So that's why it is preferred that if you put it on the top.
And the heat sinks, you need to, if you buy the
Yeah. Yeah,
case.
there is one of the component is Raspberry Pi 4 cluster case with cooling fan and heatsink. So they provide you everything. They provide you the heatsink there. We
Into the heat sink.
it's just basically a sticker type heatsink. So you can just peel off the sticker and put it on top of the uh, on top of this IC.
They come with this fan,
And these are the fans that we are talking about. So these fans basically helps the Raspberry Pi boards to cool down.
right? And you can connect the
Yeah,
pins with the
and there,
GPIO ports.
yeah, yeah. So to power on this fan, so you need to connect it to the GPIO pins available there. So you can just connect it to the pin 2 and 4, I suppose, right? Or
2 and 3.
2 and 3. Okay.
The red one goes to 2. Yeah, the red one goes to 2, and the black one goes to 3.
So if you count it from top right, then you will get the second and third pin in that way. So basically, it's a similar instruction for all of the nodes that you are installing here. So and the what we, what we did earlier, we basically stacked all the nodes one by one on top of another, and it's the same instruction you need to follow for everyone. It's very easy. You can just watch the video that we made while preparing this cluster. There is another video available. We'll share the link uh, at the bottom of this video, and we will find it there. But it's very easier and it's very intuitive. So if you feel that yeah, you are lost somewhere, you can just watch the earlier video and you will have the idea how to assemble it. But pretty much it's very simple task. So you can just use a little bit of your imagination, and you are just good to go. So this is what it looks like after the final assembly, and
Here
you
are
can
the
see, yeah,
markers.
yeah, you can see the three Raspberry Pis are stacked together, and we are showing the memory card port there. So this is the top one, which we could refer as master, and the bottom two are referred as nodes.
And we have
So
the
and now we will insert our external storage. For us, it's a flash drive. You can also connect SSD drive or external hard drive here. And
with the master.
before you turn it on, it's very essential that you connect the storage beforehand.
Yeah, and
So this is what it looks like after the full assemble. Now the main task will be to prepare the memory card. So, but So our next step is to prepare the microSD cards for Raspberry Pi operating system. So let me share my screen. So you can see from the screen that so how to do this is very simple and straightforward process. First, you need to download the latest version of Raspberry Lite operating system using your Mac OS or Linux terminal. This can be also done from Windows. For Windows, I think the instructions are a little bit different, but I believe the people who are interested, they mostly have Linux or Mac OS system. So we prepared it in that way. But these are very intuitive. You can use even your Windows computer and search for similar commands or equivalent command um, for what we are using. So how to download this from terminals. So it can be also downloaded from a browser, but we'll prefer to do everything from the terminal. So first we will download the Raspbian operating system using this command. And then after successfully uh, a successful execution of this command will end up with a zip file which is called raspbian light latest.zip. We will unzip it inside a folder. Then after unzipping, we will end up with a .img file with a date on which we just downloaded. So this basically looks like something like this. Now we need to insert the microSD card to one of the laptop port. So you might have a adapter or some external device where you can just insert your
I'm just
microSD
using
card. Yeah, something
it's
like
a
this,
card.
or maybe something more sophisticated. It depends on what you have. So this is basically straightforward. And then you will just write this command to on your terminal to see what are the device you have on your devices attached to your computer. For Linux, the equivalent command will be lsblk. Now, if you check carefully, then you will end up with a list where you will see your pen drive or the external drive is connected to your computer. For us, uh, it was attached to dev disk 2. For you it might be different. Just check for the memory and just check for the external storage that you are using, and you will find out who in which mount point it is mounted. Now then
Typically, you know the size of the memory of your
yeah,
device. I mean, the
yeah,
card you can identify from there which disk.
exactly. So you know your what is your storage for your computer, and the external storage is most likely less than your original storage. So you can just have the idea of which storage we are talking about, and the number will be always larger than than your internal storage, and it should be mounted at a defined mount point. So for us, it was dev disk 2. Then we just unmounted the disk, and then we flashed the image to the memory card. So this is again the very straightforward command. So you need to understand this name will always change based on the date that you downloaded this Raspbian image. Yeah, the date will be different, and the rest of the thing will be most likely the same.
The
Now,
last one, the disk 2 will also change. If you
and
have mounted the stuff in disk 3 or disk 4, you will have to change it to disk
yeah,
3.
exactly. So based on the mount point of your external storage, you need to change this number as well. Now,
Right.
after
Since
success,
since this is in sudo mode, you'll have to provide your machine's computer's password
yeah.
to run this.
So there might be a limitation for some computers or some user who doesn't have administrative access to the computer. So you should be very careful which machine you are using. But I can assure you that this is simply the least thing you need to worry. You can do this in a different way. There are different tools available for Windows. I believe there are some disk mounting tools available. You can just install the application and use your pen drive and flash the image there. So that is very straightforward there. But we wanted to give you a flavor how to do everything from the terminal itself, because we are talking about high performance computing, coding. So so terminal and headless mode of operation is very much popular for the coder. So we are planning we are trying to give you a flavor of that. Now
It
after
takes a while as well. It takes a while as well because if
yeah,
this is something like 300
yeah,
MB or so, depending on the speed of your connector, it will take some
yeah,
time. So don't worry.
yeah, that's a very vital point, because you need to have much patience here, because to flash this image to your drive, it depends on a lot of different factors. The
For example,
factor
my machine, it took around 20 minutes for each
yeah,
card. So that's why I have already
yeah,
flashed it in every micro SD card. And so I have just this stuff copied in every card. That's it.
yeah, we wanted to minimize the total length of the
I
video.
mean,
So
I don't
this
need like 60
yeah,
minutes, like
exactly,
20 into 360 minutes.
exactly. So just follow the instruction provided in this document. We'll provide the link as well there, so how to find this document and where you can get this thing, and just follow this instruction. And we believe that it has been tested multiple times that it works every time. So you don't have to worry that it will not work. Just follow, read it carefully and follow the instruction. Then you will end up with 3 different memory cards where every one of the memory card is flashed with this Raspbian light image.
At this point, there is no distinction between master and nodes, master node or working nodes. You have to
Exactly.
follow the same procedure for all the memory cards, which are
Ex
going in master as well as in working nodes.
exactly. Now, one of the important part here, since we are using headless operation mode, that means we will not have any access to uh, physical keyboard or any of the things where you can access to the Raspberry operating system manually. So we will connect to the Raspbian systems using a SSH using SSH. So to do that, we need to create a blank SSH file in each of these image. So we will while after flashing the image to this memory cards, we will go inside the operating system, and particularly it will be mounted under boot, and then we will create a blank file named SSH inside this boot directory, and we will do this for three of the memory card for each of them. So it will allow us to connect to the Raspbian system using SSH. Now, next part is network setup. For this, we'll demonstrate you uh, how to set it up, how you will configure your router and then connect your Raspberry Pis to the router, and how you will assign IPs to the Raspberry Pis, because assigning IPs to the Raspberry Pi is very important, because we are going to communicate with the terminal, and through using just Ethernet cables. So it's very important that
Right.
we put right IPs to the right Raspberry Pi system.
Right. If you know the IPs in previous, then it will be very easy for you to configure the master and the working nodes. Because if you know the IPs, then you can put them in the script,
Yeah,
and then automatically the everywhere in the script it will take care of which identifying which is which node, which is working, which is master. If it is working, which number it has.
yeah, yeah.
Right.
So setting up the router is pretty much simple, and we have tried to provide you as much information as possible in this document. So for our case, we are using a TP-Link router, but you can also use D-Link or Netgear or whatever network router you have access to. Then just follow the instruction. It's pretty much simple. So our router will be connected to the internet as well, but we are connecting to router to our computer first using a Ethernet cable, and then we'll configure the router before connecting the Raspberry Pis to the router, so that the whole network will be in our hand, and we can control the IPs, how and what IP will be assigned to which Raspberry Pis. Because this particular method that we are trying to demonstrate here is the automated method. So in automated method, we'll just run few scripts, and all of the Raspberry Pis will be ready to operate. So that's why it has to be very specific. You need to be very specific about the IPs as well. So let's. I will stop sharing the screen, and then we'll demonstrate how the network is configured.
Right. Should I share the screen now?
Yeah, you can see.
Right. So if I just scroll down, here you are.
Yeah. So we are right at the network setup phase. So first, what we will do, we will first connect, first power on the modem router, or the router that you are using. So we're using TP-Link router. So we'll connect or power it up with the powered cable, and then we will.
Like
Yeah.
this.
So this is the router that we are using today. So you can see. So this is a pretty simple router, and we have four LAN ports and one for internet port. So if you see the left blue one, it's called the internet port, and we will connect a network cable to
Right.
the
This
internet
will
port.
come from the machine.
Yeah.
So we
So
connect it.
so so it will be, so this cable will come from your original router, which is
Right.
basically provides you the internet to your home. So,
Right.
and then rest of the cables are basically three of them are for Raspberry Pis, and one will be connected to the computer. But at this point, we'll just power on this router and connect the main cable to it.
Just to show these three cables that I'm showing here, these three cables, these go here.
Yeah.
In these three ports. These three cables. This goes to my laptop.
Yeah. So the first step will be we will turn on the power.
Takes a while to come.
So the first step to do this, to set up this network, is to connect your laptop or whatever device that you are using to configure this whole cluster. So you need to connect your system to the router and using one of the Ethernet cable that you have, and just connect the laptop to the one of the LAN port available in the router. So if you connect it, and if you go to your network preference or network setting, whatever you have based on your operating system that you are using, so you can see. So this is basically we are using a LAN adapter for our system. So you can see the IP address that has been assigned to our laptop using the LAN port. So we have this IP address 192.168.0.100, and the router IP that we can see here is 192.168.0.1. So this is the router IP, and we can configure our router just typing this IP to our browser. So just copy the browser this IP and put it on one of your browser tab, and if you just paste it there, so you will end up with this page. So based on the router that you're using, maybe the D-Link, maybe Netgear, so you will end up with this. So if you just look at the back of the router or side of the router, you will get the information what is the default username and password that you should use. So for us, for TP-Link, the username would be admin and the password would be admin. So it's a basic setup. And the default mode. So if you put it there, it will end up with this page. We will not configure everything. So we will just go to the network first. We'll set the IP different because we need a different one here. So just go to the network of this page. Yeah. So then you can see this is the connection type is dynamic IP, but we will not do that. We'll put a different IP. Just change the dynamic IP to a static IP and put the IP address as 10.10.10.0.1. So it's you're configuring WAN. It's not the WAN, it's the LAN. So just put it back whatever you had. So just put just change the static IP to dynamic IP, and then then go to LAN and then change this IP. It should be 10.10.0.1 for the method for the steps that we are using, but the script that we are going to use, we need to put it like that. Yeah. Now just save it. Yeah. Now it will reboot. Then press OK. So after rebooting, the address that you're using to access this router will be changed. So let's wait for that. It might take, I think, 1 minute or less than that. Just wait for that. Okay. So you can see this number is getting increased. And of course, it will reach 100, and then then it will reboot.
I guess it just takes a minute or so.
Yeah.
It does not take much time. side because we will be following some commands from the GitHub page, and we'll be executing
Yeah.
it in the terminal.
Yeah, but it's a very straightforward process. So I feel it should not be a big problem for everyone. So yeah, now we can log in again. So now we will check if the LAN IP has been changed. Of course, it would be. So just go to the network and then click on LAN. Yeah, so now we have LAN IP 10.10.0.1. Now let's go to DHCP. So here we can see, so it has already enabled some of the things, but we don't need this. We need something different. So we'll put our start IP address at 10.10.0.11. No, so let's start with 10. That would be
Yeah.
great. So 10 will be 10 will be the first device connected to the system. So our laptop is already connected to the system. So our laptop, so the IP assigned to our laptop will be changed to 10.10.0.10. And the end IP address we can keep whatever it is right now. Then the default gateway is of course there. The DNS server we should change it to a different one, so we can put the famous 8.8.8.8, and the next one should be 8.8.4.4, and then we will save it.
Yeah, so this just means that if so the laptop that is currently
Yeah,
connected
yeah,
will get the IP 10.
yeah,
Next device, whichever I will connect to this, will get a IP 10.10.0.11. If I add one more, it will be 10.10.0.12 and then 13. So if I connect the master node first with this network, the master node will get the IP 10.10.0.11. Working node 1 will get 10.10.0.12 and then 13, since we have just two working nodes. So yeah, so this is how we will get a control
yeah,
over the IPs. We
yeah,
can,
exactly,
since we
exactly.
know who is the master and
Yeah,
who are the individual working nodes, we can use it in the form of a script much more easily. So this is the precise reason we are doing this.
exactly.
It gives basically a lot of flexibility.
So now we have saved the settings. So now we will check what is our IP on LAN. So just go if we just go to the DHCP client list and refresh it. So it's still saying that we have this IP 10.10.0.100. So yeah, we can do one thing. So we need to make sure that it's not 100. It should be 10, so that it doesn't mess with our system. Okay. So let's go to the DHCP settings again, and then try to put start IP address 11 instead of 10. Okay. So our laptop will be at 100, but next system that we will connect will be 11. Okay. Okay, so now DSCP, if you go to the DSCP client list, it's still showing our laptop is at 100. Okay, that's fine, and let's keep it in that way. Now next we'll connect one of the Raspberry Pi, which is called master node, to the network. Let's do this, and we'll keep this page on and
Right.
wait for the master node to appear here, and we'll check if the IP of the master node is 10.10.0.11. That is very necessary. So by any means, we need to make sure that our master node has IP 10.10.0.11.
Connecting
Yeah.
this
So
stuff with
so so we right now we are connecting the master node with the network. You can see here. Okay. We still haven't powered it up. So
right into the power as well.
so still it's connected to the network, but it's not powered up. So it will not assign any IP right now. So first,
You can power it up with something
yeah,
like
yeah, yeah.
this is the
So
standard box.
so the next step will be to power it up.
Right.
So let's do this. And you can also share your screen just to make sure that we can see the DSCP.
Right. Let's just refresh. There's no change.
Yeah. So now if you just connect your Raspberry Pi master, we're expecting it to be.
Right. It's just got connected.
So we need
So
now
if it's connected, there's a small red light. You'll see.
Yeah, yeah.
Stop sharing. This is the red light that is blinking here. Ow.
Yes, so you can see a small red light that's being appeared there. So it basically shows you that okay, the board is powered on, and yeah, you can now check what's happening there.
As soon as you power on, you get
Yeah,
the fans also working.
yeah. So now we'll refresh this page and see if it's been there. So the client name will appear as Raspberry. So you may have to wait 1 minute or so. It might take a while to boot up because it's the first time the operating system is being loaded from the memory card, so it might take a while, but it will appear. So let's see. And if it doesn't appear even after 1 minute, so there might be a problem with the network itself. If the cables are connected correctly, just check your router. If the lights are on and it's properly connected to the machine, if everything is fine, then it should appear in no time. Just wait a bit.
Yep.
So we'll keep replacing. So yeah, so now you can see. So there is another machine so the client name is Raspberry Pi and the assigned IP is 10.10.0.11. So okay, so now we have our masters.
Right. Anyway, if you connect it with the power, you'll see one LED is blinking, and if your network connection is perfect, then you'll see in the network port, you'll see a light is blinking.
Yeah.
So
now let's do the same for the other two nodes one by one. You can connect other two nodes as well right now. Then it will assign the IP 12 and 13.
Right now?
Yeah, we can do that.
Okay. Let's go one by one.
So the reason why we need to do this one by one, because we are making sure that the IP that is being assigned to this Raspberry Pis is in the order that we want. And another thing, one clarification that we need to provide is, so this is the method where we are using DHCP to assign the IPs. But if you feel that, okay, I don't need this, I just want to assign the IP by myself, just disable the DHCP and set the IP by yourself. And that will work enough. So there is no need that you need to follow the same thing here, but you need to make sure your master is assigned the IP 10.10.0.11 and the other nodes 10.10.0.12 and 13. It should be at any cost, otherwise this script will not work. So now we have connected another Raspberry Pi to the network, and we're refreshing the page and waiting for the confirmation that we have the right IP there. Yeah, so you can see now we have another Raspberry Pi with IP address 10.10.0.12. Now we'll do the same for the third one.
Light is on.
So let's wait for.
Yeah, I guess it's not very difficult because
no,
once it's connected,
yeah,
you see the lights are blinking.
Yeah,
yeah. From there,
there are different indications that you can make sure that okay, it is properly connected, and that we are using. We try to show you how to configure this router because it's very straightforward and simple thing. You just follow. You can just use it for any of the router available in the market. The settings are
Right.
almost the
Right.
same. So you
There
need
is nothing specific about
yeah,
this that
yeah,
we.
yeah. So just follow their individual page. Try to set the line IP first, and then put the DSCP on and put these IPs. And again, I'm just repeating itself that if you don't want to use the DSCP, if you just want to assign the IP by yourself, you can still do that. Just configure the network by yourself, but that might be a bit harder. So that's why we're using. So now you can see 3 of the Raspberry Pis are connected to the network, and they have been assigned the IPs that we wanted: 11.12, 11 and 12 and 13. So now we have proper control over the IPs
This
of
will
the
be the
Raspberry Pi.
master. This will be the working node 1.
Yeah.
This will be the working node 2. That's
So,
the.
so these names that you are seeing here under client name is the default host name. So we'll change it to a proper proper conventional method. So the first one will be assigned as master, and rest of the things will be the node 01 and node 02. So let's move on to the next part.
Right.
So
Sure. Yes.
now, yeah,
Close.
so we don't need this page anymore, but we will keep it there in future, just to check that if the client names and the host names are being changed or not properly. So the next step is the configure the master node. So just go to the bottom of the
Right. So
script.
you can just check this. So we are at this
Yeah,
step.
yeah,
Master has 10.10.0.11, 10.10.0.12, and node 02. So we'll be calling this Raspberry, which is client name
yeah,
Raspberry. We'll be calling this as master. This one we'll be calling it as node 01, and this one, which is again this thing, we'll be calling it as node 02. And we'll change the host names, and later on these names will be changed.
yeah. So all the informations are there. So there is one test that you can do here. We can just try to ping every device. So you can see we can just we are pinging the master node and it's responding. We can do the same for 11, 12 and 13.
Yeah.
But
Okay.
okay, so let's go to the step 3 without further delay. So now we need to log into the master node. So just we'll copy and paste this command. It's pretty straightforward. SSH. We're trying to log into the master node using SSH. Pi is the username, and followed by the IP address of the
Right.
master.
Right. We are just going to.
So we'll just copy the command to the terminal. We can just log into the master node using SSH. So if you just since we are connected to the master first time, so it will ask if you want to connect your and then type yes and then enter. So it will ask for a password. The default password is Raspberry. There's also provided on this instruction page. You can see it's in italics font, so it's called Raspberry in small. Then if you type that, then we are inside this master node. So it's still not master. We're calling it master. So it's a default host name that you can see. It's the Raspberry. Now after executing one of the scripts that we prepared for masters, it will go to mission. So next command is to copy and paste this onto the terminal of your master. You can see. And so it will basically download one of the scripts that we prepared and available on our GitHub repository, and then it will ease the process. So just press copy paste the command and press enter. So now it has been downloaded. You can see. So it's called master underscore deployment.sh. Now one thing for sure, before executing this particular script, we need to make sure the external storage that is being connected to the system is connected to the proper mount point. So we expect this external storage to be mounted at SDO1 and /dev and /SDO1. So type this command lsblk, press enter. Then you can see this our 16 GB. This is basically which gives us 15.1 GB actual memory is mounted under SD1. So It is expected that if you connect any external storage, it will be mounted under SDA1. But if it doesn't, you need to make sure that you change this particular set of commands mentioned here, mkfs.ext4, and this euid commands, and you need to change these commands inside the master deployment.sh. So if you just type ls on the terminal, if you can see there is a file called master deployment.sh. So just edit this file and change these values. For us, we don't have to, because it's mounted under SDA1, and the script has been prepared in a way that it should work for SDA1. So just you need to make sure that it's under mounted. But
It's just
we expect that it should be mounted under SDA1 for everyone else. So that is what we tried here. So now let's do the second step, which is to execute this bash script. So copy the command and paste it onto your terminal. And press enter and then wait. One particular problem that you might face here, if your router is not properly configured to the internet, if it is not connected to the internet, then this part will not execute. So it is very essential that you connect your router that you're going to use for this to the internet port of your main router, or your at the LAN port that you're using in your institutes or schools or colleges or wherever you are trying to do this. So yeah, it might take a while. So it will take quite a lot of time, because you can see a lot of packages are being updated, because there's a command inside the script which is called update and upgrade. So it's basically updating all the packages and upgrading whatever packages already installed there.
something that takes time.
Yeah, it takes time, and also it depends on the network that you are using. So if it's a faster network, you might
Right.
end up within less time compared to others. So it is not particularly bound to the machines. It depends on the network.
Right. Maybe we can talk a little bit about the code, the script a bit.
Yeah, we can talk about scripts. We can talk about Raspberry Pis, what they.
Right. One very familiar doubt that people have is, I guess, what is the difference between a Raspberry Pi and an Arduino?
Yeah,
Because
this is
Arduinos
very
are,
common.
right. Arduinos are very common. Many people use Arduino. So the question may be, many people think. In fact, I also once thought, can we make a cluster with Arduinos instead of Raspberry Pis, or how much the computational power is different? How much is the power consumption is different for Raspberry Pis and Arduinos? You want to make a comment on
Yeah,
that?
yeah. It's a very popular question, and I think there are a lot of internet resources available that one can, of course, search for that. But I will try to make a gist out of the information. So basically, Raspberry Pi and Arduino is a very different architecture. So Raspberry Pi is a single board computer. It's called also called as SBC, where Arduino is a microcontroller board. So this is a very different thing that we are dealing with here. And so being a microcontroller, the options are very limited. You cannot install a operating system there. So it's already very limited options there. But
Mhm.
for Raspberry Pi, it's basically a single board computer, or it can be used as a laptop. That's why you can install different operating systems there. You can install different programming languages. You can write your own scripts, right, and compute in different languages. But for Arduino, you need to use a Arduino interface to program that module. So
Right.
there is a vast difference. And again, another important part will be the processor that both of the boards uses. So for Raspberry Pi, they use ARM-based processor, which is right now very popular. If you are familiar with the latest trend of MacBooks, they used to use Intel boards, or yeah, 86 64-bit architecture, but now
Mhm.
they moved on to ARM-based processor there. So and Raspberry Pi is already using ARM-based processor for.
I guess one important motive for using ARM-based things is the power consumption.
Yeah. that's very efficient for power consumption.
Because I
ARM-based processor is
the
very,
Raspberry
very good.
Pi takes 1/10 of power of a laptop. Is it correct?
Yeah,
Or
yeah, yeah, yeah. That's very true. So we'll also talk about this. Let me just finish about the processor itself. So if you just talking about the processor, so we have a clock speed of 1.5 gigahertz for Raspberry Pi. Compared to that,
how much is it
Arduino
for
has
this?
a, I think 16 megahertz or something like that. So
So
or
that
less.
is bigger. Yeah.
Yeah.
So there is a
So,
huge difference.
so there is a big difference between this computational power that we are talking about. And if we talk about the power consumption, so there is also very different because since it has less computational, less clock speed, it uses less amount of power to operate. So if you just compare with the Raspberry Pi for idle mode, that means if you don't connect any peripherals to the Raspberry Pi board, it consumes around 3.4 watt or something, or similar to that. And if you connect all the peripherals, it goes up to 7.6 watt. Uh, um, and there are different variants of Raspberry Pi as well. Like so, we are talking about Raspberry Pi 4B. So the data that we are providing is for Raspberry Pi 4B. But there is another Raspberry Pi which is basically equivalent to an Arduino board, which is called Raspberry Pi Zero. So for Raspberry Pi Zero, it takes around zero point 0.5 watt, only zero point 0.5 watt, just for minimal operation. And if you connect all the other peripherals, it goes up to 1.75 watt.
Right.
For
So I
for
guess
Arduino, yeah. So for the Arduino board is I think it's similar to the Raspberry Pi Zero, but it's of course always smaller than the Raspberry Pi 4B.
no. So if I look at the clock speed, you said it's something like 1.5 gigahertz for,
Gigahertz for Raspberry Pi. Yeah,
and for
exactly.
Arduino it's in megahertz.
Yeah.
Just to give a comparison, how much is this for a laptop? It's in 2.3 gigahertz or so.
2.2, yeah, most of the laptop starts from 2.3, 2.2 gigahertz, and it can go up to 3, but is the 3 gigahertz laptops are very
So,
expensive.
so essentially, if I have a truly parallel architecture, then I have like for two Raspberry Pis, its computational efficiency is equivalent to a laptop. Right?
Yeah, that you can say. Yeah, that you can say very easily. And another thing is the price point. So you also asked me about the price point. What is the price difference between different board and computer and a laptop? So the Raspberry Pi costs you around $35 to $52, and compared to that, Arduino boards are like $12 to $18. So there is a big difference in those boards. And if you go for a laptop, you can imagine how much price you have to pay for a laptop
Yeah.
compared to the Raspberry Pi boards.
For
Okay,
example,
so we can
that
see that one of our process is finished, right? Yeah,
right. These Raspberry Pis we are using for 2 GB boards. So these were like $30 or so. So
yeah,
essentially, in $100, I got all the three Raspberry Pis. I will never get a
yeah,
full-fledged laptop in $100.
exactly.
But I don't have a display though. Yeah.
Yeah, that's true. That's true.
Yeah.
But
Anyway,
but yeah,
so
you can use your existing displays for that. But for laptop,
yeah,
yeah, it's a built-in thing. But anyway, so because there is a different use for different things. So yeah.
right. Okay,
So
so this has got completed.
yeah.
And so this says that at the end of the script execution, the system will automatically reboot. So now it's
So you can see the terminal says rebooting system. Please wait. Connection close to this. So that means it's being rebooted. So now if we have to wait, and we can look
just
for if the host name is being changed. So if you go to the router page
right.
there, so and try to refresh it.
Fresh.
So yeah, it has a default timeout setup. So every time we do not do anything on this management page, it automatically logs out.
Right.
So now if you go to the client list, you can see now the client name has been changed to master. And since it is live and we can see it from the page, so now we can so it is confirmed that the system is alive, and we can just log into the system again. Just use the same command ssh pi
And
at the rate
same
of tab
password.
ip, and password is the same raspberry, and we are in the system. So you can see now we have a system with hostname master.
Maybe we can just check it out. If I have it. Yeah. So earlier it was Pi and the Raspberry.
Earlier it was the default
Yeah.
host name, and now
Oh,
we have a different host name. It's
um,
called master. Now we need to prepare the nodes as well. So
right.
let's do that.
No, before that, maybe we should run for the command.
This should be
This is the
executed.
difference you
Yeah,
can note here. We have
yeah.
in the script also we have written Pi and the Raspberry, and here we have Pi and the
And now we have master. Yeah, and we need to do this for the shared storage that we are using. It should be accessible to all the other nodes, and it should be writable. So we are just allowing all the permissions.
Remember, shared directory is the pendrive that we are using, the
Yeah.
small one,
Yeah.
16.
This shared directory is basically our external storage that we are using.
Yeah, you can use it as scratch.
Yeah. Now we will set up the worker nodes. So for that, we will open another terminal tab. So this is a fresh terminal tab. Now we'll log into the node.
So we are in step 4 now.
Yeah, we are at step 4. We will
Step
try
completed. Now in step 4.
Yeah.
And we'll just log in for the first time. You'll have to
again.
And then say Raspberry. It's the same password. And again here. So this will be our node 1.
Yeah.
We'll have to copy this.
It's the same process. Copy and paste onto your terminal. And then press enter. So now it is downloaded the script. Then
just remember, for the first node you'll use node 1.
Yeah.
For the next node you'll have to use node 2.
You have to make sure that you
be very careful about this.
Yeah. If you do it for the other node, you need to change this node 1 to node 02. That's very essential.
And if you don't do that, you'll have to start the process again and flash the memory cards again and do it from 0.
So while we are doing this, we can go for the master deployment script, and we can just try to explain some of the things.
Right.
Okay, so this is the script that we're using. So we'll try to explain it in a simple way. So we will not go into the extreme complexity that we went through to make this easier for you who are going to install this. So the first part that you can see here is basically we are setting it in a so this set E
separation.
It basically enables the system. If it gets any error, it will exit. So yes, it will not execute further, just to make sure that we are not doing anything that is unwanted, because this is a basically systematically executed script. So one thing has to be executed completely in a perfect way, then only the next thing should be executed. So that's why it is very essential that we are not doing this thing repeatedly. So this is the second part, is the script has to be run in super user mode. So that's why we are making sure the user runs the script in a super user mode. Otherwise, it will just give you an information that, okay, rerun as root. Next, we are updating and upgrading the system. And then in line number 15, you can see we are installing several different packages, which are basically essential to configure the Raspberry Pi system as a cluster. Now, this next step is to clone the GitHub repository that we prepared for this particular set. So this basically says cloning GitHub repo, and this is the repository that we were working with. Now we'll particularly after cloning the repository, we will enter into the repository directory, then check out to the automated branch where we prepared the script, and then we'll allow the Pi user to change the permissions there, and then we will enter into the data that we need to copy to the machine itself, because this is very important. So we have different configuration data to configure the master. So now the 24 to 27 helps you to set and change the host name of this computer. So it was earlier Raspberry Pi. Now we are changing it to master. Then the 30 to 32 is basically we are setting the time zone. This is one thing which is important. If you are living in some other place in US or maybe in Europe or in some place in the world, try to change this particular part. We
Yeah,
haven't met.
you just have to change this,
Yeah,
like
yeah.
nothing else.
This, yeah,
Just
yeah.
this.
So if you change this one, it will automatically detect to your zone and then it will set the time based on that. Next is where the NFS share that we are trying. So we are basically creating a shared directory, and we will
Basically,
try.
remember the pendrive,
Yeah.
the small pendrive that I
So
showed.
37 to 39 is basically we are creating a blank directory, and we'll try to mount this pen drive or external storage to this directory. So this is basically a creation of the directory, and then the 44 is basically we are formatting the drive external storage, and
There is some
47.
data earlier in the.
Yeah, exactly. We already explained that part, and 47 to 48 makes sure that that it when the Raspberry Pi boots up in the next login, it will basically mount this external directory to the particular mount point that we are referring, which is called shared directory, and then the 50 line number is basically allows the system to mount the external storage that we are configuring as an NFS here. And then 52 in using 52, we are making sure this storage that we are adding to the system, which is also called as scratch, is available to the network. So other while setting the worker nodes, we'll put the same instruction to the worker nodes so that they can fetch the shared storage from the network itself.
Right.
And 54 is basically we are implementing what we added, what are the instructions that we added to 52 number lines. So it's basically NFS system. We are exporting the NFS system that we implemented in the master, and then we try rebooting the system, and that's what we could also see from the net on the screen. Now let's go to the node deployment script. So while this is being executed, we can also explain the node deployment script as well. So there are a lot of different things we're trying to avoid. We are not trying to jump into the details of everything.
This
So this
part,
is
there is no point of repeating this.
this part is similar. So this is nothing. So this is how we are making sure that the argument that we are passing to the script, which is for the first system, we use the
The
argument
beginning
node.
register,
Yeah,
this
the
one, not
node
zero one. This
01.
is the argument one. So this is
Yeah,
basically $1.
yeah. And for the next time, if we change it to node 02, so the node number variable will be changed to node 02. For
Right.
right now, it's node
If it
01,
is
which
$1 for every
yeah,
script, so there is no need to change it this to $2 or $3.
exactly.
It is the first argument. That's
So do not need to change anything in this nodes and the deployment script for nodes. The only thing you need to change
maybe
is from the command line
I
argument. Okay, so now we are the node 1 is ready. So we will log into node 2. And so to do
maybe
that, we can just we
yeah.
can catch
Oh,
the so no, this is node 1, and other thing is not connected to the network, maybe in some way. So can you check it? And for some reason it's not connected to the power, maybe. We'll try to ping the system first. Try to ping 1.13
right.
if it is on the network. If it is not, so it's
So,
showing that it's on the network, but still it's not showing here, which is very weird, but it doesn't happen often. So okay, anyway, so we'll say consider that this is on the network. So let's try to log into the system. Then we'll be sure, okay,
yeah.
this is
You
something that we
can
have.
note that the name of
Yeah,
node one has got changed.
yeah, exactly. So it was earlier Raspberry Pi, now it's not 01. For some reason, the router is not showing our 10.10.0.13, but
Remember to
still,
change it to
yeah, yeah,
13.
yeah. So there's an instruction that we have shared there, like you need to repeat the process for every other node. So this is the second node that you're using. So you can see this is in the same network, and we can just log into the system using this command. Now we need to do the same process, copy the command to download the script and paste it onto the terminal for node 2. And press enter. So now we have downloaded thing. Now make sure that you are changing this node 01 to node 02 while you're implementing this. So put node 02 there, and it's running perfectly. So let's go back to the node deployment script, and we'll try to explain.
No,
yes. So now it's
appearing.
Yes, it's a small network glitch, so you don't have to worry about it. If you can connect to the network, or if you can at least reach to the node by pinging. Right. So this is the best. Yeah, this is the best way you can just test your network. Just ping, ping.
Right.
Okay. So we are setting the node number by using the command line argument. So we now passed the argument node 02 right now. Earlier it was node 01. So let's talk about node 01 first. Now, first, 15 to 17 will give you just so it's basically updating this operating system and then the software packages. And the slide number 17 we're installing several packages.
Note that the master deployment and this node deployments have different installation stuff. So here, it's not the same line.
Yeah. So this is basically if you just follow the other instruction method that we earlier presented in the other videos, so we try to explain it in a different way. So we try to do it manually, but now we are doing it all together. So this is basically, and if you just compare it by side by side, you will understand what's happening where. Okay. So next one is we are doing the same thing. We are cloning the GitHub repository for this particular set of instructions, and we are checking out to the automated branch and then doing the same stuff. But we are going to copy the configuration data from the nodes, and here we are. So the host name is being changed to respective node number. For node 1 it was node 01, for node 2 it was node 02. And then we are adding the proper information to the hosts. Okay. Now next is 34 to 36, where we are setting up the system local and keyboard. Is same as the master. And the most important part is the shared storage. So what we are doing here, we are creating the shared directory here as well, but we are configuring it in a different way. So the shared storage
is again different from the master deployment script.
Yeah, exactly. We are the mount point of the shared directory here is 10.10.0.11. So this is basically the master. So because our external storage is connected to the master, so we have to mount it in that way. So and then we are just executing the command that and after this command it should be available to all the nodes. And for smooth operation, we are again rebooting the system. So then after the reboot, we'll see the name of the host name is changed to node 02. So then we will have 3 different Raspberry Pi with 3 different host name. One is master, and another 2 is node 01 and node 02.
Correct. So we have repeated this process, step 4, twice, because for the first one was for the first node, second one for the second node. And then after that, we will be configuring SLARM.
Yeah, we'll be at step 5.
Always not necessary. If you want to use the SLARM type job managing if you're wanting to use it for an HPC, and if you want to use a SLARM type, then you can use configure Islam. Otherwise, you can leave step 5 and directly go to step 8, I guess. Or something. Okay. Coming back to our discussion on the power consumption of the Raspberry. Do you remember? I don't remember the numbers. Do you remember how a Raspberry Pi is? I mean, how much power does it take compared to the laptop? We learned that it is not comparable with Arduino maybe, but for power consumption with respect to
Just it's a
something
simple,
like a
simple.
1/10.
So there is simple comparisons. Like for a standard MacBook, the charger comes with a 60 watt, 60 wattage charger,
Right.
right? So you can understand. So you are using a 60 watt power source, power
Yeah. Right.
charger,
Like
and
1/10 or something
yeah,
like this.
yeah. And but the comparison is not exactly the right thing to do, because you can understand, for a laptop we have a battery attached to the system, so you need to charge it faster as well, and if you need to charge it faster, you need a more powerful adapter, right? So that make a different sense. So but if you
No,
compare with
that's
the
a
desktop
that's a
system.
different thing. I'm just wondering if I'm making a cluster of CPUs and if I'm making a cluster of
Yeah,
Raspberry Pis, which one will be less consuming the power?
yeah, of course. So the Raspberry Pi will be right.
Yeah. But
It's
maybe
just
there are some issues with
it,
the scaling.
it, it depends on different things. One is the peripherals and the onboard system that you have. So Raspberry Pi is very limited in that perspective. It's a small board, so you have less power to waste there, right? So it's
Right.
very compact. So
So how do you
it's,
cool it?
yeah. So the cooling part, there are different things that you can get. So first, the most efficient or most easy way is to use of course the using cooling fan and air cooling. But there are different methods available. There are pretty cool ways to do that. One is the water cooling method,
Yeah.
so which are I think there are several websites or several companies or small scale companies, they're building this kind of setups. I can share the information that might be very convenient at this point of time. So just I'm just sharing the screen. Maybe that might be easier for right now, or should I do it
We'll
later?
just go there and launch the.
Yeah, that might be better way.
Okay.
Okay, so we should not waste any time. We should utilize the time in a good way. So you can see here right now we have three different Raspberry Pis. One is master, another two is Node 1 and Node 2. So next step would be to configure SLAM on the master. But before
And
doing that,
you
we
have
will.
to be logged into all the working nodes simultaneously when you're launching
Uh,
this master, right?
it's not mandatory, but yeah, it could do that. It might be easier because we have some of the instruction as well to perform on the nodes. But the main thing that we need to do here is to configure master first. So the next step is step 5, configuring
Right.
SLAM
So
on
we are
master
now
node.
in step 5. Yeah.
So now we followed the instructions. So we have just logged into the system, and now we will use the next command, cd to Wi-Fi deployment. Yeah. So now we are inside the deployment directory, and now we'll run this passwordless SSH for masters. So it says it's successfully executed, and it will allow us to communicate with the other nodes uh, very efficiently. We don't have to use any passwords to communicate with the other nodes, so that makes our life easier. And the next step is to run this SLAM configuration script for masters. Yeah, just copy paste and enter, press enter.
Would you like to tell what is this RSA key and stuff that we have found here?
Yeah, but this is the way it communicates with other machines using SSH. So the RSA key makes sure. So this is not only for this system. This is also applicable for any system that any Linux system or any system that uses SSH. So this is basically the full form of SSH is secured cell, right? So we are communicating through a secured cell, but mostly we use the passkey. That means we use password to log into another system. But when you use this RSA
It's
key,
something like a finger.
exactly, this is basically a fingerprint, unique fingerprint created by the system itself. And if you send this fingerprint to the system that you want to log into, then It's so you can compare it to your mobile that you use. So you put your fingerprint and it opens up, and you don't need to use any password. So for SSH it is the same. If you create a RSA passkey and if you pass it to your to the remote system that you want to log into, then you can communicate in a very efficient way. You don't have to use any password.
Right.
Just communicate with SSH and put the address of the
Right.
host name.
Right. Now we need to configure the SLAM on the compute
So
node as
so
well.
now the SLAM configuration master is completed. So next is to configure the SLAM on compute nodes. Okay, so
Right.
we have already logged into the system, right?
Right. Do we need the master to be on when we will be
Yeah,
working?
You have to make sure that the master is on.
So
While
this will have to be logged into the master.
again, so the thing is, you don't have to log into the system. If it is on, then it's okay. But you have to make sure that it's already on. It's not booting up or
Right, it's
something.
not turned off yet. Right.
Okay, so you need to make sure that it's turned on. Okay.
Right.
Now we need to configure the SLAM on compute nodes. Just put the command. And now we are inside Wi-Fi deployment, and then run the bash script. So it's completed and it's rebooting. We will do the same for the next node 02.
So if you have like 1,000 nodes, you'll have to do this same
Yeah,
thing.
exactly. But remember, it will not work for this configuration script because we have not configured it for
Because
1,000 yet. But you can do this just by just editing the scripts. So you need to add more information to that. If you just okay with it, you can go for it. Okay, so
let's wait for this to resurrect because if I do node 2,
yeah.
node 3.
So this is a diagnostic check. So since our SLAM will communicate with the other nodes with Manje, and we have a Manje key that has been installed in several other machines. So this is another thing. So we can use SSH passwordless SSH, but for SLAM to come, the master node communicates with the other nodes with Manje, and so we need to make sure that it's perfectly communicating with the other nodes. So and the command for that is this SSH pi at the rate of node 01 Manje this. So we'll log into the master node and we'll check if it can communicate with
Right.
the other two
You
nodes.
need to make sure that you are on master.
Yeah. So yeah,
we have come back on master.
Yeah, that's true. So we will do this for both the nodes. So first we are testing node 1. So you can see the status is success. That means it can successfully communicate with the nodes. And then we'll try it for node 2. It should be the same. Yeah, it's the same. So it's successful. Okay. So now we can test the SLAM system. It should be up and running. So let's start and try to find if our system is running. Okay. So it's sinfo. Now it says the system is at idle with 2 different nodes, and then node leads at node 01 and node 02. So we can just test a bit. We can run this particular command, which basically uses SLAM to run the hostname command, and it will give us node 0 and node 02. Basically, it's running the hostname command to both of the nodes. That's why we are getting as output as node 0 and node 02. Okay, now this is not essential, but we have prepared this for to make the life easier. As simple as that. So you can make it make
Do we need to show this powering on and off now? Or should
no, we will not show you the power on and off, but we will try to show you the temp check. So you can just try these commands by your own, the cluster up and cluster down. And it is essential that after operating everything, you need to shut down the cluster. So to do that, use the cluster down command. And if you turn it on for the first time, then you need to put this command cluster off. Okay, so right now we just tried one of the command, which is called temp check. You can see it will give us the temperature of the different nodes. So master node is at 32 degrees centigrade, node 1 is at 33 degree, and node 2 is at 36. So okay, so we are done. Next step is to test OpenMPI and Slab. We will do some little bit programming here. So now we have already copied some of the directories that and the program that we are using for this demonstration. So you can go to this
At this
directory.
point, we don't need node 01. We can just come out from this. Right?
Yeah. So node 0 and node 02, we don't need anything. We will communicate with only master. So now go to master only, and then we will just do our stuff because it's a cluster and your login node is master. So you just go to the master node and execute these commands. Then we will compile. So if you put ls there, you will see inside this directory we have the C programming file, which will use MPI open, and we have this host file where we have the information for all the nodes. So if you have different number of nodes, you can just put the information there. And this is a sample. This is just a simple hello. Is the first thing that you can start with. So we'll try to compile the program with this command mpicc.
Right. Oops.
Not there here.
Okay. That's fine.
Yeah, so it's successfully compiled. Now we'll run it with using MPI run.
Right.
Yeah. So it's giving us something like this, which is basically expected. And if you change that NP2 to NP4, then we'll use 4 different processors. Yeah. Okay, so it's successfully tested. Yeah, we can go up to, I think we can go up to 12, right?
No, 8. Right.
12. We have
right.
3 different.
We're not using slum, that's fine.
Yeah.
So let's go up to 12.
Okay. Yeah, so it's done.
Let's try to go to higher than 12.
So if you go to higher than go higher, it will not give you the result because it will say, okay, we don't have enough processors to execute the command. Okay. So it's successfully tested, right? Okay. Next.
Okay, so we should say every Raspberry Pi has 4 cores. Since we have 3 Raspberry Pis, it has 3 into 4, 12 cores. That's why we could go up to 12 processors.
Yeah.
And as of now, we are using it in the simple MPI way. We are not using one as master, one as 2 as nodes. So that's why we have all the 12 processors available. If we are using it in the SLARM way, if we are submitting the job through master, we'll have only the working nodes available with us. So we can run it on only 8 processors, not all 12. So that is something to
do. Yeah, that is quite I think important information, because if you have this system and if you want to fully utilize the system, then you can go with a simple MPI other than SLAM. But anyway, we will test the SLAM as well. So we have this SLAM jobs directory where we have these 2 different files. One is hello mpi.c, is the same program that we had there. But we have a extra thing which is called the SLAM script. So this is a basic structure for a MPI for a HPC job, which you want to submit it using SLAM. So here we have this information. You can see the number of nodes that you want to use, number of tasks per node. So
this task per node is the processor.
Is the number of processor that you want to use per each node. and partition is pi cluster. So we configured our system, and the cluster name was pi cluster. If you type sinfo, then you will get this information. What is the partition name?
So right now, if I launch this run, it will run on 4
Uh,
into 2 equal
two,
to 8.
yeah, we will have 8 different.
If we put it more than 2, it will be something
Yeah,
thing that it
it
will
will not
not.
run, and it will hang there. It will not run, right?
Right, it will be just in the queue, hanging in the queue.
Yeah. Yeah. So next is we will submit the job with SBAS, and you will see if we try SQ, you will see the job has been
Yeah,
submitted, and the job ID is 3.
right. It was just when it was combined.
Yeah.
So we can see here.
Yeah.
It's
so
a
this is the
pi cluster.
yeah, exactly. And this is the name of the program, name of this. I think there is one part where we can mention the name of the job, and now it's done. You can see.
Right. It just take 2 seconds, or probably even less than that.
Yeah.
It ran on 2 nodes, and node 1 and node 0.
Yeah.
If I do now ls,
Yeah, you will get an
I
output.
had only these 2 files. Now I had this executable and this file, this output file. You can just log into this. We can just go into this and then see.
Yeah.
This is
so this is the output that we expect. Yeah. Yeah.
If we come out, suppose we go to, I edit this to 3.
You need to put an extra exclamation. Yeah, now we can run the script again. So the job number will change and it will increase 1 by 1. So now we are trying to run a job with 3 different nodes, but we don't have any. So it's now showing the partition configuration. That means we don't have the right amount number of nodes available to run this particular task. So it's now we need to kill it to continue further. So let's kill. So it's called cancel, and the job followed by the job ID. If we again check SQ, we'll see there is nothing. So if sometimes it is there, but it's not being cancelled for some reason, just cancel the job, and that's all.
More if I do just simple, you can see it's
yeah. So it's an idle, so it's ready to take more jobs. So that's all. Right. So we have executed every instruction available on this information page. And yeah, now since all of our job is done, now we can just execute the command cluster down. And this will help you to shut down the cluster. And
right. Before we go into that, would you like to explain these configuration scripts?
I think the rest of the scripts are pretty much straightforward. The main thing was preparing these nodes, and so it's asking us to, do you want to shut down the master node as well? Because sometimes you want to shut down the no compete nodes, but not the master one. So so there is an option, but if you press yes, then it's shutting down the master. So now we're out of the system plus verify. So next time you want to use it, you need to make sure you need to power it up again. So you need to switch up the main power that is being connected to the system, and then you're good to go.
Okay, so this shows that it's perfectly clean, and within a few hours you can make a cluster, HPC cluster, for your own in your house.
Yeah, this is a demonstration to show that it's very easy. You can do it by yourself. Just follow the instruction, and rest of the things will work in a simple way. But even if you have any trouble or if you have more questions, you can contact us by writing us. There in contact information available on the instruction page. You can find it in some place. But and yeah, and that's all. Thank you for watching this video, and I hope you'll like it. And that's all. Goodbye from us.